so we're trying to find the hydronium ion concentration and the pH of nitrous acid. Is that how you say it? Yeah.
I think so.
That's how you say it. Of a 0.10 mole per liter solution.
My arms.
Another tutorial video?
Yeah, it's lovely.
Those are so fun.
Mother of science.
So now we got that.
Oh, look at that. Nice writing.
Very lovely, isn't it?
Oh yeah.
Your plus sign right there.
Oh yeah.
Oh, we also need a negative. We also need a negative.
Oh, on the
NO2.
Oh, shooby-doo-bop. Science for the win. Oh, okay. We need a plus, not a star sign. Okay. Oh man.
There we go.
Professional reaction.
We got this. To find what we need, we make a nice table.
To see stuff. Cross out the liquids. Liquids are liquids, and we don't need them in an aqueous system. So we got 1/10 of a mole per liter on the hydrogen nitrous side. Nothing here. Now, of course, we don't know stuff, so we gotta find stuff. Pretty X stuff. So we use a polynomial or kind of a integer or algebraic letter to find what we need to find. So, you know, this reaction is very products favored. We gotta get rid of some of our stuff. So this side will gain some of the...
It'll gain the X, the other one won't.
Yeah.
The other side, and then minus. Yeah, X minus. The thing is, we don't know what X is, and we're lazy, so we don't want to do, we don't want to use the quadratic formula. So,
Yeah.
what's the rule called again?
Oh, that rule.
Approx rule! That's, okay.
So,
Anyways, so with that approx rule, X pretty much equals nothing.
yeah.
So,
All rounds up to 0.10 anyway.
so it's gonna cancel out, so we don't need the ice table anymore.
Time we'll be finding the Ka acid. A, not Kb. Sorry, Kb. We'll get to that. Another video. No, we won't, because this is the only video we're making.
terrible already.
Basically, the Kc expression is basically products over reactants. So we'll substitute Kc for Ka. It's basically a ratio comparing what is made with what we had. So then, if I can kind of lean over and try and write things, and hold the board still. Basically, we'll write what we had in our reaction, but without water, because that's a liquid and we don't need no liquids in an aqueous system. Hydronium content, which came from a hydrogen transfer from the hydrogen nitrate. Go. If you look back earlier in the video, we have our HNO2 reacting with water. There was no coefficient, so everything is in a nice 1-to-1 ratio. So we can basically, the amount of moles in the hydronium will be the same as the nitrate. So what we can do is we can simplify the expression. Kind of nice how math does that too. Very nice. You know, seems to be math in everything nowadays. And here we go. I mean, why not put hydronium? We're looking for hydronium anyway. So there we go. Now what we gotta do is we don't know what our hydronium is. And thankfully for HNO2, we do have a Ka value. And of course we have our 0.10 moles per liter concentration. So it turns out to be, Ka is 5.6 times 10 to the negative 4. Whiteboard, stay still, please. This is our hydronium. That's what we're looking for. Got to do some X marks the spot, be a pirate, discover things, find treasure. And if we find the treasure, which is hopefully a good mark, depending on our video and penmanship skills. So we gotta actually rearrange our formula. We gotta find x, multiply by 0.10. That kind of moves here, and then we gotta want to go find the hydronium concentration, not its squared component, so we can do some square rooting there, kind of rewrite it in a more neat and organized fashion. So there we have our acid concentration multiplied by our Ka.
So we're looking for x, right?
Yeah, looking
And x equals
hydronium stuff.
hydronium stuff, yeah. So x equals that.
Wait a minute, how'd you get up there?
Before the lovely stuff ended, he explained this. So that just equals the square root of 5.6 times 10 to the negative 4 times the concentration. So 0.1 moles per liter.
Oh yeah.
Once you do that, the answer is, because I'm so good at math, x equals 7.48 times 10 to the negative 4, 3. To the negative 3. Okay? So that's x. So that's our hydronium. So x equals H3O, positive.
Pretty fancy.
So that's what that is. To find the pH now, you take this and you do negative log of x, or hydronium. It's the same thing.
I mean, yeah.
Of 7.48 times 10 to the negative 3, and that gives you pH. pH equals 2.13.
2.13. That's very acidic. Yeah.
It's very acidic.
Yeah. And acidic things, if you get it on your hands, it gets really spicy really fast. So